All right, today we are doing section 1.4. This is the last section in chapter 4, and this one is solving systems of equations. So you may recall from Algebra 1, when you have two linear equations and we're trying to simultaneously solve those, one of the methods we use was elimination. Well, now we're going to look at, instead of solving two equations with two unknowns as you did then, we're going to solve three equations with three unknowns, x, y, and z. And we're going to run through this problem using the elimination method. Okay, so the first thing you're going to want to do is look at these equations and say, okay, can I manipulate one of them so that when I add two of these equations together, one of my variables drops out? And if you look at number 3 right here, if I multiply this whole equation by 2, I'm going to get a negative 2y right here. Well, and then if I add it to this first equation, my y's are going to disappear. So that's what we're going to do first. We're going to multiply this equation by 3 and then add it to the first equation. So when we when we multiply everything in here by 3, this is my new equation. And then I'm going to just add those two together. This is number 1, and this is my new number 3. When you add those three together, or those two together, the y's cancel. Hopefully, that's what I wanted it to do. 4x plus 12x is 16x. 3z plus 8z is 11z. 12 minus 6 is 6. This is going to be now my new equation number 1. So now what I want to do, looking back at the third equation, if I multiply this equation by negative 3 and then add it to the number 2, the y's are going to drop out that time. And I'm going to get another equation that has just x and z in it. So we're going to go ahead and do that. We're going to multiply this one, number 3, by negative 3. And when we do that, we get negative 18x plus 3y minus 12z equals 9. One of the biggest mistakes people make when they're doing this method, if you're multiplying one of your original equations by some constant, that we tend to forget to multiply everything, and that includes the constant on the right-hand side. So don't forget to do that. So when I add the new number 3 to my old number 2, I get this. Negative 16x minus 7z equals 2. And this is my new equation number 2. So now notice, this has just an x and a z, and so does this one. Oh, and look at this. This is negative 16x, that's a positive. All I have to do now is add those two together. So I'm going to add the new number 1 and the new number 2. It's this right here. And when I do that, those drop out, the x's drop out. 11 minus 7 is 4z. 6 plus 2 is 8. And then divide by 2, so z is 2. Now you're going to plug that number into my new number 1 up here to find x. When I substitute 2 for z in that equation, I'm going to get 16x plus 22 equals 6. Subtract 22 from both sides. 16x equals negative 16. And we can't see that, sorry. So x is negative 1. Now, we have z, and we have x. We're going to go back into one of our original equations and plug z and x into it to solve for y. I chose to substitute it into number 1. So I'd have 4 times negative 1 plus 2y plus 3 times 2 equals 12. Magic algebra. Solve for y So y is equal to 5. And that gives me the solution, and this is how you would write it: x, y, and z. This is called an ordered triple, because this is now a straight line in 3D. Okay, well, guess what? You can use your graphing calculator to do this. And I'm going to show you how, by using the matrix option on your graphing calculator. So this is the system that we're going to solve. You could probably go ahead and pause here and write this system down so that you could follow all the steps to do it on your calculator and get familiar with that. I'm going to rewrite this whole thing as a 3x4 matrix. And we call it a 3x4 matrix because it has 3 rows and 4 columns. So this is always row, this is always column. And this is what a matrix looks like. So how you do this, this is just the coefficient of the first x term. This is the coefficient of the first y term. This is the coefficient of the first z term. And this is the first constant. So if you do this properly, all of these are the coefficients of the x's in our 3 equations, right there. These are all the y coefficients, these are all the z coefficients, and these are all the constants that are on the right side of the equation. And here are your steps. Oops, wrong paper. Okay, I can't get the whole page on there, I don't think. I'm going to try. Sorry. Yeah, I can't get the whole page on there. So I would go ahead and pause right here, copy down what you can, hit play, and then copy the rest of that. Okay, if you've done this correctly, let's talk about this for a second. When you have your matrix stored in the proper place, and then you're on your home screen, you're doing the calculations, this right here stands for reduced row echelon formula. Do you need to know what that means? No, you do not. Just know that it works. If you go to college to become a math major, you're going to learn all about that. But we're not going to spend time talking about that now because we just don't have the time. So when this comes up on your home screen, and the way we read this is the x equals -1, y equals 3, and z equals -4. And there's my ordered triple right there. So what happens if you're using the calculator to do this on a system that has infinite solutions? That means anything you put in for x, y, and z is going to work. Well, you're going to get a matrix like this as your result, except this bottom row will all be zeros. And what that means, you're going to end up with 0z equals 0. Well, 0 equals 0 is a true statement. Remember that anytime you are doing this solving systems, if you end up with a true statement and no variable, that we know that those are infinite solutions. Well, what if the system has no solutions? In other words, those 3 lines don't ever meet at the same point in 3D space. When that happens, you're going to get 0, 0, 0, and then a 1 is going to be here. What that means, then you'd have 0z equals 1, which is 0 equals 1. Well, 0 equals 1 is false, not equal to 1. And anytime you come up with a false statement, then we know that there are no solutions. So I encourage you to make sure you have these steps in your notes because that's sure going to help you when you have to solve a system on a test or a quiz. One of the problems with doing a system of 3 equations with 3 unknowns by hand is there are multiple opportunities to make mistakes. If you're using your calculator, as long as you enter all the elements correctly, it's not gonna give you a mistake. And we will definitely do one of these in class next week before you take the quiz or the test, so that you have some more practice doing that on the calculator. That's it for now. Chapter 1 is done.